Hello, we are Palate Pal. We have a 7-year-old patient that has arthrogryposis multiplex congenita, or AMC for short. This is characterized by congenital joint contractures in 2 or more areas of the body and affects 1 out of every 3,000 children born. Our specific patient has no mobility in her arms or hands, meaning she's unable to feed herself. That dependence on a caretaker has led to our patient having little self-confidence. Our overall problem is that the patient is unable to grasp or lift eating utensils. This problem affects people with limited mobility in their upper extremities, such as people with AMC, ALS, muscular dystrophy, MS, and amputees. And our hope is to make an affordable assistive eating device that allows this population to eat independently. So altogether, we need a cost-effective way to enhance the ability to grasp or lift eating utensils in patients with limited upper extremity mobility to improve eating independence.
We have identified the problem in our population. We have now come up with a solution. Our design process consists of 3 components: the plate, a robot and buttons, and utensils. Our first component is the quarter circle plate. Shown on the left is our 3-lane plate in 30-degree increments. At each 30-degree increment, the utensil will scoop through the center of the lane to lift up the food. Shown on the right side, we have the reverse side of the plate, which we shelled out material to make it lightweight. This will allow the patient to bring it to different places, and it's making it more affordable and portable. Lastly, for the materials for the plate and the utensil, we chose a FDA-approved polymer, so it's dishwasher safe as well as biocompatible with the foods.
Our second component is the robotic arm and buttons. Shown on the left is the Tinkerkit Bracio robot that we purchased to be the robotic arm. It is controlled by an Arduino Uno, as you can see up on the right. The buttons that are used to control the robot will be mounted on a housing next to the robot, and there are 3 buttons for each lane. The user is able to use their torso to bring their nose to push each button to select which lane of food they want to eat, and there's also a start and stop button.
The next portion of our device is our utensil and utensil attachment. These are models of Creo Parametric. They are both made the same material as the plate. The bottom left, you can see how the utensil is rectangular and it has a flat portion because will push against the plate to pick up the food. If you look in the center of the screen, there's a portion of the utensil that will be shimmied into the utensil holder as seen above, and then that utensil holder will be attached to the robotic arm, and then the bottom right shows the combination of the 2. This is an engineering drawing of the utensil holder to show how the utensil will be shimmied in.
So this is our robot in motion, which is showing the success of being able to scoop food from the plate. So as you can see, the robot brings the food up for the user to eat from after the button push. And as you can see, we have only manufactured 1/3 of our plate. This is due to problems due to coronavirus and cancellations and things shut down on campus. However, in the future, we are hoping to get back to campus to be able to manufacture the full plate and utensil and to do software safety testing, failure and fatigue testing on the material, as well as drop testing. And we really hope to be able to expand our product out to all those patients that Taylor had mentioned.